Hello everyone and welcome to AWS Serverless Labs. Today we are going to be focusing on one of my favorite service, which is Amazon SQS. For this video though, we are going to be looking at the fundamentals. I'll be taking you through a process of creating a queue using the console. Of course, you can do the same using the CLI, the SDK, or the API. But for this video, we are going to be creating a standard queue using the console. And through that process, I'll be explaining to you what each of the queue attributes mean. And if we still have time at the end, we might also look at how you would create a FIFO queue, because it's different from a standard queue. But that depends on how much time we have at the end, because I'm planning to keep this video short since it's just an introduction to SQS. All right, without wasting any time, let's get straight to it. As you can see from the screen that I'm already logged into the AWS management console. In fact, I'm already in the Amazon SQS console. Of course, you can do the same. If you are logged into the console, you can just search for SQS here on the search bar, and simple queue service should come up. Just click on it and it should bring you to this screen that you are seeing right now. To get started, let's create a queue. And from here, you can see that we have to decide what kind of a queue we are going to create. There are two types of queues when working with SQS. One is the standard queue, and it says here that it has at least once delivery, and also it has best effort ordering. So at least once delivery, meaning that you might have duplicate, you might have a message that's delivered more than once into the queue. And also it has best effort ordering, meaning that while the service does try to order the messages, there is no guarantee that the messages will be kept in the order they came into the queue. And on the other side, we have a FIFO queue, first in, first out delivery. So the ordering of the messages, it's guaranteed, meaning that the first message that comes into the queue will be the first message that leaves the queue, or the first message that is processed by the consumer. So that's first in, first out delivery. On the other side, we have exactly once processing. So it has some features that allows you to ensure that duplicate messages are not introduced into the queue. So if that's your use case, then probably you should go with FIFO instead of standard. But before you decide which one you are going to use, I encourage you to just go through the documentation, because there are some limits that only apply to FIFO queue, like the TPS limits that only apply to FIFO queue in terms of like the throughput as compared to the standard queue. So before deciding which one you are going to use, just check the limits or the quotas documentation, so that you can be sure that the system will be able to handle your load. All right, for this video, like we said, we are going to be looking at the standard queue. So we're going to select standard queue here. For the name, let's just give it AWS queue, and we come to the configuration section. The first thing we see here is the visibility timeout. I'm not going to read through this. Basically, the visibility timeout allows a message to be hidden or locked while it's being processed, to prevent other consumers from reading the same message. When you send a message into SQS for the first time, that message becomes available. So it moves from your system, your producer, and the first state that it assumes it's the available state. And that means that any consumer that tries to read messages from that queue will be able to read or receive that message from the queue. Now, immediately, as soon as a consumer reads a message from the queue, SQS locks that message while that consumer is processing it. And the duration in which that message is locked for, it's based on the time that you set here. For example, the default is 30 seconds. That means that for 30 seconds, after the consumer has read the message, has received the message, for 30 seconds, that message will be locked. Other consumers will not be able to see that message. They won't receive that message. This is to prevent duplicate processing. Ideally, you should set this time based on how long it takes your consumers to process one message, maybe on average. So you should look at how long your consumers take to process one message to ensure that whatever value you set here, it's above that to avoid duplicate processing. Because if this value is low here, it might happen that while one of your consumers is still processing a message, that message becomes available again. So that would be after the visibility timeout. In this case, let's say after 30 seconds, your consumer hasn't deleted the message. It's still working on that message, and that message becomes available again. Then now you have a situation where another consumer, another thread might pick up that message, and you end up in a situation where two consumers, two threads, two applications are processing the same message. So to avoid that, make sure that you set this value to give your consumers enough time to process each message. So that's the visibility timeout for this. We'll just leave it at 30 seconds. But as you can see here, you can set it from 0 meaning that messages are always available, or 12 hours. 12 hours is the maximum, and this it's a hard limit. So you can't contact AWS to try and get these to be increased. That's a hard limit. And then we also have the message retention period. The default is 4 days, and the maximum is 14 days. The retention period is basically how long the messages will stay in the queue. If the message is not processed after the set or the configured retention period, that message will expire and it will be removed from the queue, and there are no ways to recover it. Even if you try to reach out to AWS, that message is removed from the queue and you can't recover it. So you need to ensure that messages are processed within the retention period. What you can do, you can set up alarms. There are metrics that you can set up alarms on to just check if there are messages that have been in the queue maybe for longer than 3 days, 4 days, to ensure that you do something with those messages before they expire. And then we have the delivery delay. This feature allows you to delay messages or delivery of messages to an SQS queue. What happens here is you can send a message now and set a time here to say this message should only be delivered in 10 minutes. What happens in the background is that the message is actually in the queue, but it's hidden from the consumers. So it has a flag with the timeout, and that timeout will basically be counting down. And once that time expires, that message becomes available, meaning that other consumers can read or can see that message and they can start processing it. So if your use case has something to do with delivering some messages, then this is the feature that you can use. The maximum is 15 minutes. Again, this is a hard limit. You can't increase it. This is the 15 minutes is a hard limit. And then we also have the maximum message size. Nothing much to talk about here, but 256 is basically the maximum message size. You can send objects or files, messages that are larger than 256, I believe, using S3. If you're using Java, there is an SDK. It's Amazon S3 extended SDK or something like that. So you can use that SDK to send messages larger than 256. Basically, how that works is instead of the message coming to SQS, the object would go to S3 and on SQS they'll send like a pointer to where the object is in S3, and whenever you are making a call to receive the message, you basically go to SQS, get the pointer, and then the SDK would then go to S3 and retrieve your file from there. Even that has a maximum though, I believe it's 2 gigs. So that's something to look at if you have messages that are larger than 256. And then we have the receive message wait time. The receive message wait time, we have 2 ways on SQS on how to read messages from the queue or receive messages from the queue. You can use what it's called long polling, or you can use short polling. Long polling means that you make a call, an API call to the queue, and if there are no messages in the queue, you set some time there to say that call shouldn't return until after 5 seconds, or that call should only return after 10 seconds if there are no messages in the queue. However, if there are messages in the queue, as soon as that call finds a message in the queue, it will return back to the caller. So the minimum is 0. If it's 0, it means it's short polling, meaning that there are no delays. The call would go into the queue. If there are no messages, that call would return to the caller immediately. The maximum is 20 seconds. So if it's 20 seconds, it means that you make a call to the queue. If there are no messages, then that call will wait for 20 seconds. If after 20 seconds there are still no messages, the call will return to the caller with an empty response, what is known as an empty receive on SQS. What this helps you with is saving cost, because on SQS you are charged based on the number of requests that you make towards a queue. So if your queue it's not very busy, doesn't have a lot of messages, then you can set it, for example, you can set the receive message wait time to 20 seconds so that you're not frequently making those calls to receive messages when the queue is empty. So that's an advantage of using a receive message wait time. However, at the same time, as soon as a message is received, it doesn't wait for the full time that is set for the receive message wait time, meaning that you don't really experience any delays in terms of the performance. For this, we'll just leave it at 0. And then now let us move to the policy part. We have the access policy. When you are working with SQS, there are 2 major ways of controlling access to the queue. One way it's using an access policy. An access policy, it's basically a policy that's similar to the IAM policy. If you are familiar with the IAM policies, it's similar to the IAM policies. However, it's attached to the queue. You can use this policy to control who has access to the queue. Of course, another way of doing it is using IAM policies to grant access to your queue. By default, the queue does not have an explicit deny. That means any IAM user or role who has the policy to read, to write, or to manipulate the queue can do that. That's one thing you need to note. As long as you didn't put any deny statements on the policy, anyone who has the permissions in your account, of course, this wouldn't work with cross account. In your account, anyone who has the permission to do that would be able to access the queue. And if you don't want them to access the queue, if you don't have control on their IAM policies, then you can put a deny statement on the access policy so that only certain IAM roles can access your queue. However, this one, it's mainly used to give access to other services. For example, if you want S3 to send messages to SQS, since S3 doesn't really use a role, then you would use the access policy to explicitly allow S3 or give S3 permissions to write messages to the queue. Or if it's SNS, for example, SNS doesn't really use a role, then you would use an access policy to grant SNS permissions to send messages to your queue. Or in terms of Lambda, you can still use an access policy, but since Lambda has a role, ideally you would want to put those permissions on the Lambda role. So in the same way, when it comes to roles, users, ideally you should be maintaining those accesses or permissions on the IAM side. But any service that does not use a role, then you would use an access policy to give them access to the queue. Another place where it's used, it's in cases of cross-account access. If you have maybe an IAM role from account A trying to access a queue in account B, then you have to explicitly allow that role or that account access to use your queue. So I can't just access anyone's queue because I have a user who has admin rights. Those admin rights are only work for my account, but won't work for cross account. So for cross account, I would need to ensure that on the other account, on the queue side, I have a policy that allows access, that gives the other account access to use my queue. So that's another place where you would use the access policy. And one thing to note about access policies is that there is a limit. Forgot what the limit is, but there is a limit for the policy size. So that's one thing that you need to just be aware of. All right. Okay, let's continue. As you can see, there are two ways here. You have the basic and you have the advanced. So if you wanna do basic stuff here, and then SQS would try and help you with the policy, or you can go to advanced if you know what you are doing, and you can just edit the JSON and add whatever it is that you want to add. All right, let's go down. Okay, now we also have the redrive allow policy. The redrive allow policy, basically you select which queues can use this queue as a dead letter queue. On Amazon SQS, you can create a dead letter queue and associate them with a source queue. A dead letter queue, basically, it's another queue that is used to receive messages that failed processing in the source queue. For example, suppose you have QA, that's my source queue, and then I have QB, and QB it's my dead letter queue. Then if there are messages in QA that are not getting deleted or they are not being processed for whatever reason, I can tell SQS to isolate those messages for me so that they don't block processing on my main queue, and send those messages to QB. Then QB would be my dead letter queue. So in this case, on the redrive allow policy, you basically tell SQS whether this queue can be used as that QB. Can it be used as a dead letter queue? And if so, you can specify which queue can use it. You can specify whether deny all, meaning that there is no queue that should be using this queue as a dead letter queue. This actually, it's a recent feature. Before, you could select any queue and make it a dead letter queue, which was obviously a risk because some of those queues were production queues, so you end up with messages that are not supposed to be in that queue. So now they've added this feature where you can deny all, meaning that no one can use this queue as a dead letter queue. They can't specify it as a dead letter queue for their main queue. So that's a good feature to have. And of course, we also have encryption. This is encryption at rest. Obviously, if you are using HTTPS, all the messages are encrypted in transit. But for encryption at rest, you can select, you have two options. You can use Amazon SQS key. This is also have been recently added. Before, they used to only to be SSE KMS key. When you're using SSE KMS key, just be aware that your consumers or your producers might need additional permission to work with KMS, and also be aware of the KMS limits and also charges that comes with using KMS. You can also see the calls that your consumers and your producers are making on CloudTrail. And also on the Amazon SQS documentation, they do have a formula that you can use to try and estimate how much you would pay for the KMS if you're using KMS key, or you can just use the SQS key to encrypt your messages at rest. Lastly, we have dead letter queue. I think I've already touched on this. Again, it says here send undeliverable messages to a dead letter queue. So you can enable this, specify which queue you want messages to be sent to. Just be aware, if you are using a standard queue, then your dead letter queue must also be a standard queue. If it's a FIFO queue, then your dead letter queue must also be a FIFO queue. And you specify the maximum receives. This is known as the receive policy or the redrive policy. You specify the maximum receives. Basically, how many times should your consumers read or receive the message before sending it to the dead letter queue. So if it's 10, that means that your consumer will make an API call to receive a message, read a message from the queue the first time, and if for whatever reason it can't process it and that message is still there, and then it makes another call until the count is incremented to 10. And after that, SQS will notice that, okay, this message has been read 10 times, therefore it shouldn't be sent to a consumer. Then they'll just remove it and send it to a dead letter queue. So this is a nice feature to have. Okay, and then we have tags, obviously, as with a lot of other AWS services. We have tags. You can set up tags here for cost allocation. And for this one, I think I only have the basics, but we can click on create queue. And basically that's it. Your queue is ready to go. You have the URL. The URL is basically what you'll be using mostly to communicate with the queue. If you're using the SDK, using the CLI, the API, most of the time you'll be using the URL to communicate with your queue. And we have the other attributes that we've already looked at here. But from the console, you can also send or receive messages. You can send a test message here. And we also have delivery delay. So the delivery delay, you can set it on the queue level. As we have seen when we were creating this queue, there was an option to configure delivery delay, or you can also set it for each message that you are sending into the queue. In this case, for this message, I can set it. So whatever I set here would override my queue settings. We're not going to set that here. And then also you can add message attributes. You can add up to 10, I believe, message attributes for each message that you send into the queue. And yeah, that's it. Then you can just send a message. Okay, they want a message attribute. Okay, then that's sent to the queue. And then to read the message, you can poll. And then we can see our messages here. You can see the attributes, the body, the details. What I want us to check here is the receive count. The receive count is what SQS uses to check whether a message should be sent to a dead letter queue or not. For example, here you can see it's 1. So if our maximum receive for the dead letter queue configuration was set to 1, then this message, next time we tried to read it, it would be sent to the dead letter queue and wouldn't be able to view it because it would have reached the maximum receive count. So for now, the maximum receive count is just 1. All right, what else is interesting here? You can see the first time the message was received. That's also can be useful when you are debugging messages or issues with messages. You can also see the first when the message was sent. So that's also an interesting thing. You can check, for example, if your system is slow, by looking at the time the message was first received and look at the time when it was actually sent into the queue. If the time is bigger, then it might indicate that your system, it's not really keeping up with the messages that are coming into the queue, and perhaps you need to scale up or scale out. Okay, so that's that. From here we can delete the message using the console, but like I said, you can do basically everything that we looked at here today using the CLI, the SDK, or the API. And that's about it. That's it with SQS. From here you can interact with the queue, you can send messages to the queue, receive messages from the queue, can integrate it with your systems. I have here a number of actions or APIs that you can use to interact with SQS. For example, the add permission would allow you to set permissions. I think we looked at the policy. You can use the add permission to set the policy. We have list queues. We have send message batch. So you can also send messages in batch to the queue instead of sending one message at a time. You can specify up to 10 messages. And we have the receive message call. This is the API call that it's used to read messages from the queue or receive message from the queue. And of course, it also supports all these SDKs here. If we go to the Python one, Boto3, you can see from here how you would receive a message basically using Boto3 or using Python. So SQS, it's a straightforward service. It's pretty simple to get started with, and it doesn't really have a lot of complicated features, I would say. And let's go back to our console. Yeah, that's it for this video. Next, we will look at the FIFO queues and just look at some of the differences between standard queue and a FIFO queue, when you should use one, and also the limits that apply for a FIFO queue. Also, if you haven't already, we also have one video that we uploaded previously where we're looking at SQS and Lambda, how the two services work well together. Also explained some of the scaling issues that you might come across when you're working with the two services and the limits. I encourage you, if you haven't, to just check in our channel and go through that video. And yeah, that's it from my side. Thank you again for your time. Thank you for joining this session. Please, if you like the video, like, subscribe, hit that bell notification, and see you again on the next one. Cheers.